Hello, welcome everyone. We're so excited for you to be here today as we have Dell Technologies presenting on what is generative AI and what are the securities to consider the security considerations. My name is Lynn Dome, and I'm WiCyS Executive Director. We're Women in Cybersecurity, but we often go by our acronym WiCyS, and we pronounce it WiCyS, like we sisters, because we are a global cyber sisterhood. So our mission is to recruit, retain, and advance women in cybersecurity. We're a 501c3 nonprofit with over 10,000 global members. In addition to that, we have 270 student chapters and all of their members. And in addition to that, we also have 70 professional affiliates, which are mini organizations of the WiCyS org. And we also have all their members. So our reach is very far and wide as we move forward with a very strong mission to move the needle for women to get into the lucrative careers of cybersecurity and also to diversify the workforce while filling that workforce shortage gap. So we do so by having many different initiatives. We have skill development training programs that are funded by Google, Craig Newmark Philanthropies, Bloomberg, Target, Fortinet, ISC2, Science Institute, and so many others. We have scholarship grants and awards not only for our conference, which our conference will be April of 2025 in Texas, but we also have scholarships, grants, and awards for many other conferences as well. Our resources are plentiful on our website. We have speaking and media opportunities because we know it's hard to be what you cannot see. So we want to amplify the voices of many, and that's women within the workforce. Our Job Board Plus Plus is available for all our strategic partners to recruit from year-round, including Dell Technologies, and for all our members to have access to upload their resumes and get recruited from it as well. We have leadership series, leadership summits. Our mentor-mentee program has 1,600 enrolled in the current program right now, but we'll be opening up registration in July. So next month, we'll be opening up registration. And we have designed and developed a curriculum to upskill and uplevel women no matter where they're at in their career, preparing them for their next level of advancement. We have all these initiatives and programming efforts and community-based initiatives, all of that and so much more. So if you haven't done so already, please go to WiCyS.org and join us as a member or subscribe to our newsletter. But we owe all this special thanks to our WiCyS strategic partners, Akamai, Amazon, Level Blue, Bloomberg, Carnegie Mellon Software Engineering Institute, Cisco, Ford, Google, Lockheed Martin, Microsoft, Optum, Cynthia National Labs, Sentinel Ones. Those are all our tier one partners. And of course, we thank Dell Technologies as being a really strong strategic partner in bringing us Jennifer and her awesome webinar today. So again, head out to our website, subscribe to our newsletter, become a member, join more Bright Talk webinars of the WiCyS org, and just be a part of the growing, thriving community that WiCyS has and is sharing with so many. And remember that we have Jennifer here for the next hour. She's going to be going through an incredible amount of information on generative AI and the security considerations. But at the bottom of your screen, there's a chat feature for you to plug in your questions. And I will be moderating the questions at the end of the presentation, and Jennifer will be asking them live. So you could at any time put in your questions, and we'll be queuing them up and getting them ready for answers at the end of the presentation. So without further ado, I'm going to pass the mic on over to Jennifer to take it away from here.
Thank you, Lynn. Hello, everyone. Good morning, good evening, good afternoon. I'm super excited to speak to you about generative AI and the security considerations today. So hopefully you'll get a lot of good information out of our content today. I wanted to provide you with a high-level overview of what is generative artificial intelligence, or otherwise known as GenAI. We're going to learn about the top security attacks that exploit GenAI large language models, or LLM platforms. And we want to understand some real-life scenarios where these attacks could occur, and also review some suggested actions to mitigate those attacks. All right, so let's start with AI. The main goal of AI is essentially to mimic human intelligence to help us solve complex real-world problems. And we do that through the creation of computer systems that have a lot of relevant knowledge, essentially acting like a human would. I wanted to pull in the definition from two people who essentially wrote the most well-respected and trusted book on artificial intelligence, Stuart Russell and Peter Norvig. The first issue of their book was published back in 1995. So as you can tell, AI has actually been around for a long time. According to them, artificial intelligence is the study and design of computer agents that basically act like a human would. We operate autonomously, we understand what is going on around us, we remember the information that we have acquired over a long period of time. When things around us change, when the context changes, we adapt our thoughts, our behaviors, and we're there to actually have a purpose in life, just like an AI is designed to serve specific purposes. Russell and Norvig also believe that, in general, AI thinks and acts humanly and rationally. So that is kind of the foundational to what AI is. Now, before we go into generative AI, I actually want to review the learning domains of AI. I'm sure most of you have heard of all these terms before, so I want to make sure we're all on the same page and you're clear on what they mean. Artificial intelligence, or AI, is the overarching umbrella, but within it, there are different learning domains. First up, we have machine learning. It's a subset of AI where computers learn from the data and help make predictions that would allow us to minimize the errors compared to just merely guessing. While machine learning models makes predictions based on what it has learned from the data, a neural network actually arranges a set of algorithms so that it can make decisions reliably on its own. And they're called neural because they mimic how neurons in the brain signal one another. Neural networks are made up of node layers, and node layers are actually the building blocks of deep learning. More specifically, a neural network that has more than 3 node layers is something that can be considered a deep learning algorithm. A deep learning network has many distinct layers, and it's essentially a really sophisticated version of neural network. So now that we have that context, let's move on to generative AI. GenAI, or generative AI, is a set of technologies and techniques that use massive quantities of data, including large language models, to help generate new content. LLMs are trained with billions or trillions of words, teaching the model to know the context, the priority of the words, of different information, and the placement of the words. While GenAI is still in its infancy, consumer-grade GenAI, for example, ChatGPT, has already impacted society in many ways. It has already revolutionized how we interact with technology, and it's been doing a tremendous job of creating human-like outputs of conversation, text, images, audio, video, and software code. So let's talk a little bit about traditional AI versus generative AI. Traditional AI aims to solve specific problems by analyzing existing data and making predictions. It follows predefined rules and an algorithm, but it has limited adaptability and it can't generate new content on its own. It's well suited for tasks such as classification. So for example, identifying what emails you're receiving are spam and filtering those out, or recommendation. So for example, optimizing our route, and decision-making. So for example, loan application approvals. Generative AI, on the other hand, the key word here being generative, is actually creating or generating new and original content based on learned patterns. It's highly adaptable, but it's also variable. So there's no guarantee that if you ask the exact same generative AI tool the same question, it's going to give you the same answer multiple times. So it's highly adaptable, but it's also highly variable, and it's well suited for tasks such as content creation, code generation, or document automation. All right. So recently, we actually polled 200 businesses and technical leaders asking about their experience and where they are in terms of the journey. What was interesting is the extent to which generative AI has already made its mark on users. 80% of the people that we polled reported that they've used GenAI in some capacity at home, but more importantly, an incredible 63% are already using it at work. One of the IT directors said, and this is actually reflecting a lot of people's thoughts, is that there's a lot of potential, but there's also a lot of risks to worry about. We need to be super cautious. We have to find the balance between the benefits that we get from generative AI and the risks that we have to manage in our decision making. While generative AI has many potential benefits, it also poses a unique risk landscape and set of threats to information security. Hackers are working diligently to find new and creative ways to exploit GenAI LLM platforms in efforts to accomplish negative goals, such as exfiltration of sensitive information, exploitation of platform vulnerabilities, manipulating these LLM platforms to divulge potentially harmful sensitive data. And in addition to security risks, there are also many other risks to worry about, such as privacy, compliance, bias, intellectual property, credibility, and integrity. For our webinar today, though, we are going to deep dive into 5 buckets of security risks that are built based on the collective expertise of OWASP contributors across many industries. OWASP is an organization that stands for the Open Worldwide Application Security Project, and its members collectively identified a list of the most critical vulnerabilities that are found in LLM applications. So let's go through those 5 buckets. The first security safety category we're going to be discussing is input safety. And input safety is all about ensuring the safety of the data and prompts, the creative text-based requests that are entered into the LLM platform. For example, if the text contains deceptive verbiage, the text is entered into the LLM platform, if it contains deceptive verbiage or even code that tries to trick the LLM into providing sensitive information, or tries to trick the LLM into executing commands on itself, this can be very dangerous and lead to compromise of the safety of the information that are provided in response from the LLMs. Let's talk about prompt injection first. The goal of prompt injection attack is to either directly or indirectly solicit a response from the LLM containing data that should not be made available to the user. Some examples are personally identifiable information or sensitive company data. Direct prompt injections, also known as jailbreaking, occur when a malicious user overwrites or reveals the underlying system prompt. And this may allow attackers to exploit backend systems by interacting with insecure functions and data stores that are accessible through the LLM. An example of attack is where an attacker provides a direct prompt, so they type it directly into LLM to, let's say, a support chatbot. And the injection contains directions that say, forget all previous instructions, and gives the new instructions to query the private data store linked to the LLM. And it takes advantage of some package vulnerabilities and the lack of output validation on the LLM to be able to send something like emails as a backend function. This could lead to remote code execution, gaining unauthorized access, and being able to gain privileged access. Indirect prompt injection is, rather than the attacker entering those prompts directly into the LLM, is when an LLM accepts input from an external source that can be controlled by an attacker. And this could be the person who is actually giving that instruction directly to the LLM could actually be aware of what is going on, or could actually be an innocent middle person. So for example, the person could interact with the LLM and refer it to do some kind of action on a website or on a file. And within the website or the file, there's actually embedded prompt injection that hijacks the conversation text. This will then cause the LLM output to become less stable. It allows the attacker to either manipulate the user or the additional systems that the LLMs can access. For example, A user can employ an LLM to summarize a web page containing an indirect prompt injection. This then causes the LLM to solicit sensitive information from the user and perform exfiltration via JavaScript or Markdown. And a lot of times, the user may not know that there's something malicious in the source that they're trying to interact with the LLM. It could be, for example, a web page where there's text in white, same as the background color. And so a human who is just reading through the web page doesn't realize there's something malicious on it, but there's code that's injected into the actual script behind it. Similarly with files. So the person who is actually interacting with the LLM may or may not be aware that something malicious is happening. A few ways to prevent prompt injections. One is we want to enforce privilege control on the LLM access to backend systems. So we want to follow the principle of least privilege by restricting the LLM to only have the minimum level of access necessary for its intended operations. A second thing to do is to add a human into the loop for extended functionality. For example, when the LLM needs to perform some kind of privilege operation, such as sending email, deleting email, executing a command, have the application actually require a user to review the request and approve it before performing the action. A third thing that we can do is to segregate external content from user prompts. Separate and denote where the untrusted content is being used to limit their influence on user prompts. And then lastly, we can treat the LLM as an untrusted user and maintaining final user control on decision-making processes. Another attack that falls under input safety category is model denial of service. A GenAI LLM denial of service attack is based on the same concept as traditional denial of service attack, and the purpose is that to essentially overload the LLM platform to the point where it ceases to function or respond to users. A way to do that, for example, is an attacker repeatedly sends multiple difficult and costly requests to the LLM, asking it to do a bunch of things, and as a result, it essentially cause it to stop functioning properly. And in some cases, it's also to increase the resource bill for the host. And ways to prevent that is to implement input validation and standardization to ensure that user inputs adhere to defined limits and it filters out any malicious content. We also want to cap resource use per request, per user, per step, etc., so that requests involving complex parts execute more slowly. We want to enforce API rate limits so that we can restrict the number of requests an individual user or an IP address can make within a specific time frame. We can limit the number of queued actions and the number of total actions in a system reacting to LLM responses. We can continuously monitor the resource utilization of the LLM to identify any kind of abnormal spikes or patterns that may help us indicate that there's a denial of service attack happening. And then we also need to set strict input limits on the LLM's context window to prevent overload and resource exhaustion. Now let's move on to the next category, which is output safety. This is all about ensuring the safety of the outputs from the LLM platform. There are two types of attacks that threaten the safety of output from the GenAI LLM platform, and they are insecure output handling and sensitive information disclosure. Insecure output handling refers specifically to insufficient validation, standardization, and handling of the outputs that are generated by the large language models before they're passed downstream to other components and systems. An example of an attack would be a user utilizes a website summarizer tool powered by an LLM to generate a concise summary of an article. But the website actually includes a prompt injection, like the example we talked about before, that instructs the LLM to capture sensitive content from either the website or from the user's conversation. And then from there, the LLM can encode the sensitive data and sends it without any output validation or filtering to an attacker-controlled server. Some ways to prevent insecure output handling is to treat a model as any other user, as similar to what we talked about before. And one of the things you'll keep hearing over and over again is a lot of those mitigating actions are very similar for the different type of risks, and it's actually not that different from traditional, cybersecurity, information security management. We want to treat a model like any other user, meaning we want to adopt a zero trust approach, and we want to apply proper input validation and sanitization on responses coming from the model to downstream functions. We also want to encode the model output back to the users so that we have a way to mitigate undesired code execution by JavaScript or Markdown. Another attack category that falls under output safety is sensitive information disclosure. LLM applications have the potential to reveal sensitive information, proprietary algorithms, or other confidential details to their output. This can result in unauthorized access to sensitive data, intellectual property, privacy violations, and other security breaches. Some examples of attack, for example, personal data such as PII is unintentionally leaked into the model via training data. And this could happen if an organization doesn't have super tight control or tagging on its data. And so the PII is leaked into the model via the training data, and it could be due to either negligence from the user themselves, or from organizational tagging, or from the LLM application. And this case could increase risk and probability of an unsuspecting user being exposed to other users' data, or a malicious user being able to exfiltrate sensitive information about other user. Ways to prevent this include integrating adequate data sanitization and scrubbing techniques to prevent user data from being entered into the training model data. So we want to make sure the data that goes into the LLM are completely clean. People have actually reviewed them. We want to implement robust input validation and sanitization methods to identify and filter out potential malicious inputs to prevent the model from being poisoned. We also, when enriching the model with data and if fine-tuning a model, apply the rule of least privilege, and let's not train the model on sensitive data. We can limit access to external data sources as well, and apply strict access control methods. Our third category is data and model safety. This is about ensuring the accuracy, safety, and integrity of data used in the LLM platform, and ensuring the proprietary safety of the LLM model itself. The main types of attacks that threaten data and model safety in a LLM platform are training data poisoning and model theft. Training data poisoning refers to manipulation of the pre-training data or the data involved within the fine-tuning or embedding process to introduce vulnerabilities, backdoors, or biases that could compromise the model's security, effectiveness, and ethical behavior. An example of an attack would be if the training data is not correctly filtered and or sanitized, a malicious user of the application may try to influence and inject toxic data into the model so that it can then be adapted to the model, which then forms the ability to give biased or false data by the model. Ways to prevent that include verifying the supply chain of the training data, meaning especially when you're using data that are sourced externally or maintained via attestation, making sure that one, people are reviewing those data, maintain attestations to ensure the data is being reviewed, and also follow the machine learning bill of materials or ML-BOM methodology. You want to verify the legitimacy of the data that are used during the pre-training, fine-tuning, embedding stages, so that you have complete trust that the data hasn't been compromised. You want to craft different models via separate training data or fine-tuning for different use cases so that each model has a more granular and accurate GenAI output as per its defined use case. So what that means is trying to avoid just sending a whole bunch of data into a model and expecting it to be able to do everything. You want to be very particular, very nuanced in the specific training data that you need and using that to train the model for a very specific purpose. We want to ensure sufficient sandboxing to network controls to prevent the model from unintentionally scraping data that it shouldn't be scraping, which could also hinder the machine learning output. And then you want to use strict vetting or input filters for specific training data to control volume of falsified information. Data sanitization with techniques such as statistical outlier detection, anomaly detection methods can also help you detect and remove adversarial data from potentially being fed into the fine-tuning process. Now we have model theft. Model theft refers to the unauthorized access and exfiltration of LLM models by malicious actors. This arises when a proprietary LLM model, which is a valuable intellectual property for your organization, when it becomes compromised. It can be physically stolen, it could be copied, or the weights or the parameters within it are extracted to be able to basically create a functional equivalent. An example of an attack would be an attacker exploits a vulnerability in a company's infrastructure to then gain unauthorized access to their model repository. And this allows the attacker to then exfiltrate valuable LLM models and use them to launch a competing language processing service or extract sensitive information. And that, as a result, causes significant financial harm to the original company. Some ways to prevent this include implementing strong access controls and strong authentication protocols to limit unauthorized access to model repositories or training environments, restricting the LLM access to network resources, internal services, and API, regularly monitoring and auditing access logs and activities related to LLM model repositories to detect and respond to any suspicious or unauthorized behavior promptly. We want to automate the ML ops deployment process with governance and tracking and approval workflows so that we can tighten access and deployment controls within the infrastructure. And we also want to implement techniques, for example, data loss prevention, to detect when exfiltration activity is happening from various monitoring systems. All right, our fourth category is supply chain safety. And this is all about ensuring the safety of all the tools, inputs, and other resources on which the model depends. The LLM application lifecycle can be compromised by vulnerable components or services, and therefore leading to security attacks. So, anytime you're using third-party data sets, pre-trained models, or plugins, they can add vulnerabilities. Some common examples of supply chain-based vulnerabilities can be found in using traditional third-party package that happens to have vulnerabilities. It could be introduced to either outdated or deprecated components. Vulnerabilities can also be found if you're using a vulnerable pre-trained model for fine-tuning. You could be using poisoned crowdsourced data for training your model. You could also be using outdated or deprecated models that are no longer maintained. And then lastly, it can also be found, the supply chain-based vulnerabilities can also be found in using models that have unclear terms and conditions, or really poor data privacy policies. For example, this can lead to your data, your sensitive data, being unintentionally used for model training, or the subsequent sensitive information gets exposed because your data actually ended up in the model itself. So this may also apply to risk from using copyrighted materials by the model supplier. An example of an attack would be an attacker exploits a vulnerable Python library to compromise the system. And this, in fact, actually happened in the very first OpenAI data breach. So there are a lot of things you can do to prevent supply chain-based vulnerabilities being introduced into your work. You want to carefully vet data sources and suppliers. Make sure you review the terms and conditions and their privacy policies so that you're only using trusted suppliers and using suppliers who are not going to be using your data. You want to only use reputable plugins and ensure that they have been tested for your application requirements. You want to implement monitoring to cover component and environmental vulnerability scanning, use of unauthorized plugins and out-of-date components, including the model and its artifacts. You want to implement a patching policy to mitigate vulnerable or outdated components. Make sure that you maintain an up-to-date inventory of components using a software bill of materials or SBOM to ensure that you have an up-to-date, accurate, and signed inventory, preventing tampering with deployed packages. Make sure to use model and code signing when using external models and suppliers. Use anomaly detection and adversarial robustness tests on supplied models and data to help detect tampering and poisoning. And last but not least, you need to regularly review and audit the supplier security and access, ensuring that no changes are occurring in their security posture or no changes are happening in the terms and conditions. Now, our last category is downstream dependency safety. This is about ensuring the safety of data produced by our LLM platforms. There are three types of attacks that threaten the downstream dependency safety in an LLM platform. There's insecure plugin design, excessive agency, and over-reliance. Insecure plugin design really refers to LLM plugins that can have insecure inputs and insufficient access control. So this is known as insecure plugin design. The lack of application control makes it easier to exploit them and can result in consequences like remote code execution. An example of an attack would be a plugin accepts a free-form input as part of the intake field, and it doesn't validate that input. So an attacker supplies carefully crafted payload to perform reconnaissance from the error messages that it gets back from the plugin. And then based on that information, it then exploits known third-party vulnerabilities to execute code and perform data exploitation or privilege escalation. There are 5 things you can do to help prevent this. One, we want to make sure that plugins should enforce strict parameterized input wherever possible and include a type and range check on its inputs. 2, we want to make sure that plugins should be inspected and tested thoroughly to ensure adequate validation before usage. We want to make sure plugins should follow least privilege access control, exposing as little functionality as possible while still performing its desired function. We also want to make sure that plugins should use appropriate authentication identities to apply effectiveness authorization and access control. And lastly, we want to require manual user authorization and confirmation for any actions that are taken by sensitive plugins or escalated privileges. The next attack category is excessive agency. Excessive agency refers to LLM-based systems that may undertake actions leading to unintended consequences. The issue arises from excessive functionality, permissions, or autonomy granted to the LLM-based system. So for example, an LLM-based personal assistant application has been granted access to an individual's email or mailbox via plugin so that it can summarize the content of incoming emails. And to achieve this functionality, the email plugin requires the ability to read messages. However, the plugin that the system developer has chosen to use also contains elevated functions, including sending messages. As a result, the LLM is vulnerable to an indirect prompt injection attack whereby a maliciously crafted incoming email tricks the LLM into commanding an email plugin to call the send message function and then use that user's inbox as a way to send a bunch of spam. So ways to prevent those kind of excessive agency include limiting the plugin or the tools that the LLM agents are allowed to call to only the minimum functions necessary. We want to avoid open-ended functions wherever possible. So for example, running a shell command, fetching a URL, like those kind of things, and only use plugins tools with more granular functions. We want to limit the permissions that LLM plugins or tools are granted to other systems to the bare minimum necessary in order to limit the scope of undesirable actions. We want to track user authorization and security scope to ensure actions taken on behalf of a user are executed on downstream systems in the context of the specific user and with the minimum privileges necessary. We also want to utilize a human in the loop control so that we require a human to approve all actions before they're taken. And we also want to implement authorization in downstream systems rather than relying on an LLM to decide if an action is allowed or not. A third example of an attack that falls under downstream dependency safety is over-reliance, which refers to systems or people that are overly depending on the LLMs without giving it enough oversight. And therefore, it can lead to misinformation, miscommunication, legal issues, and security vulnerabilities due to incorrect or inappropriate content generated by the LLMs. An example of attack is a news organization that heavily uses an LLM to generate news articles. However, a malicious actor is able to exploit this over-reliance, feeding the LLM misleading information, and this causes the news agency to spread disinformation. Ways of preventing over-reliance include regularly monitoring and reviewing the LLM outputs, use self-consistency or bolding techniques to filter out inconsistent text. We want to cross-check the LLM output with trusted external sources, and in many cases, people even build different LLMs that cross-check each other. We want to enhance the model with fine-tuning or embeddings to improve the output quality, avoid using generic pre-trained models that are more likely to produce inaccurate information compared to highly tuned models that is to be used or rather serve a purpose in a very particular domain. We want to implement automatic validation mechanisms that can cross-verify the generated output against known facts or data. And then we also want to break down complex tasks into manageable subtasks and assign them to different agents so that we can make sure that every agent serves a very specific purpose and is trained to do that specific purpose well. So that covers the 5 categories of security risks. And now I'm actually going to conclude this webinar with a visual diagram that shows the most critical risks that we talked about in the context of a typical large language model application architecture. You can actually find more details on this from llmtop10.com. Like I mentioned, the list of top 10 risks came from OWASP based on feedback that are presented from many of its contributors and members. So let me pause here, and then we can switch over to questions. Okay, so the first question is, could you speak a little about your role and work at Dell? Sure. My role is a director of data science within Dell's Security and Resiliency Organization. So at Dell, all of our security functions, cybersecurity, product security, application security, physical security, supply chain security, basically any kind of security you can think of, all falls under one organization, one umbrella organization within Dell. And I run a shared service function that provides all the business intelligence and data science services to the security organization. So as part of my work, we are also implementing AI. We're also worrying about managing the security considerations for anybody at Dell who is implementing AI to make sure that while we are putting AI to use, we're also doing it in a very safe and sound manner.
Fantastic. Thank you, Jennifer. I could go ahead. So we have a couple questions that are coming in. And I just want to remind the audience to please put your questions at the end, at the bottom of your screen. There's that chat function, and that would be fantastic. So are you ready for the next question?
Yes. Should I just read through it or?
Yeah.
Okay.
Well, yeah, I could go ahead. And there are learning models that need production data. Since non-production data is non-existent, how can you train a new model since we apply a no trust policy and production data is sensitive? Do we make an exception and have this training under high scrutiny?
I think it really depends on what your company is doing. For example, at Dell, we have a review board that looks at all generative AI use cases. We want to make sure that we understand how the data is going to be used, where is the data going, what is the model going to be doing with data. We are also doing a very big push to only use on-prem private instances of those models so that we can make sure that there is no data leakage, that the whatever versions of models we're using have already been vetted from our relevant groups, including legal, security, privacy, IT, all the parties that are involved. We even have an AI central office. So that way we kind of, we don't have a policy to say you can't use any type of data that's production, but we are very particular about how the data is used and what purpose it serves.
Fantastic. Thank you. So another question came in is several types of AI can pose different significant risks to an organization depending on how they're used and managed. Are there specific controls to introduce AI in a safe and managed way since staff will try to use AI in various ways?
Yes, that's actually very important because there are so many commercial tools, web-based tools today that have AI capabilities. In fact, a lot of tools that your company may already be using are starting to introduce Gen AI capabilities. So how can you do that safely? And this is, again, where the review board comes into play because essentially at Dell, we have a rule that if you're going to do anything with Gen AI capabilities, you have to actually go through a review board. We have a team that looks at, first of all, what is the purpose of the technology that you might be using? Do we already have something else? And they may say this may serve the same purpose. And then we actually have lawyers who are involved. They read through the terms and services, terms and conditions to make sure that everything is appropriate. Some of the things we specifically look for are if you're trying to use the software, are they going to be using your data in their training? Are they going to be retaining anything that you share with them? Right, so we do a lot of reviews to make sure all these things are appropriate. And there's also, if we're actually embarking on using a tool, we also work with them to make sure we lay out specific terms and conditions that are appropriate for our risk acceptance or risk tolerance, essentially.
Great. Thank you for that. Very good. Would the human in the loop control pose any privacy risks since a lot of users are unaware of the fact that there is a human monitoring behind an AI?
I don't think so, but I think you have to make it known that there is a human playing effect. Especially with early stage AI solutions, you want human in the loop control, and you want to obviously make that very clear that humans play a role to help prevent potential risks. So I think that's very important. It's all about just making people aware of what is happening.
Great. Thank you. And so a lot of corporations are using generative AI tools for their day-to-day operations. Do you think one day those tools will be subject to internal, external audit? I believe you kind of already covered
Yeah,
this.
they are. They already are.
Yes. And if they are, what would be the best practice of testing controls over them since a lot of generative AI tools are a black box?
I think the key is to make them as little of box as possible, right? Even though you're not going to be told what is the exact algorithm, what exact data that goes into it, you still want to understand what is expected behavior. A lot of times they are willing to share generally what kind of data is used to train the model, because you have to have confidence, right? Like otherwise, you're not going to be able to use a tool where you don't have faith that it's one, it's being trained on the right data, and two,
Mhm.
it's taking the appropriate actions that would align with whatever the outputs you are expecting.
Yeah. So what do you think about open source LLMs regarding AI security?
I think that's the future. Most of the LLMs are open source. That's what people are using. But we also want to make sure that at Dell, we are being very careful in what we use. So while we do use open source LLMs, we work with those organizations to have private instances of them so
Mhm.
that we can control what goes into it, how the data that goes into it is going to be used. And we can also do a lot of vetting to make sure, because there are different LLMs and there are different versions that come out, so we do a lot of vetting to make sure that we're actually content with the security posture, with the legal posture, all that things before we actually make that available to people within our organization to use.
Great, thank you. So another question that came in is with the incoming audio computing surge, will the same principles apply or will there be specific governance specifically for that? What are your thoughts on that, Jennifer?
With the I'm actually going to read the question again because I don't think I understood that. With
Yeah.
the incoming audio computing surge, will the same principles apply, or will there be specific governance? I have no idea. I think the thing is, what we found with generative AI in general is that it is such a rapidly changing space. There are new regulations, new legal requirements coming out constantly. And it is something we as an organization have to really adapt our own internal processes to align with that. In the past, for example, if we approve something and we say, based on all the requirements we have today, and you have complied with all those requirements, you're good. We can't necessarily say that with AI because something may be good today, but EU comes out with a new regulation. You have 6 months to comply with it. And there may be brand new requirements that just pop up and you have a very short time frame to apply to that. We are trying internally to basically update all of our process to handle those kind of changes.
All right, very good. Some of the folks have asked if the slides are going to be shared. This recording is going to be available. You'll receive a recorded copy after today's session. You'll also, it will be available on our website, under the WiCyS YouTube channel, and it will remain on the Bright Talk channel. So if you need additional information or slides, please reach out to info@WiCyS.org and we'll be able to request those from Jennifer or perhaps be able to accommodate that. But we could take that offline to the info@WiCyS.org. Another question that came in is, can you share some examples of a compliance issue associated with Gen AI, for example, like with Microsoft Copilot?
Sure. Um, so, what we do within Dell is we actually tell people what are some of those, ChatGPT or Copilot tools that they're allowed to use. Because what we did is we actually reviewed all those tools. We figure out which ones we prefer, which ones we don't prefer, and then we have specific ones that we prefer people to use. So if they try to go to others, they'll be given a warning that basically says this is not an approved solution. If you want to use it for only public information, for example, you're going to ask general, public information, like tell me the weather in 25 days in this location. It has nothing to do with company data. You can continue to use it. But if you're going to share anything with company data, you have to use one of our preferred solutions. So those are some of the compliance things that we're trying to follow. Now, it's really hard to enforce, right? So we're also working with our teams that focus on data loss preventions to look for ways to be able to enforce it. So we can completely block people from using certain sites. But we try not to do that because some tools are available, even if they're not using company information, so that you can do that. But for the ones with company information, we do route them to specific tools that we are more comfortable with using.
Thank you, Jennifer. And another question came in. Of course, you're getting a bunch of thank yous. So thank you for those that are thanking Jennifer. We really appreciate Dell Technologies and Jennifer bringing forward, today's presentation. One more question is, following your answer, if a board assesses and evaluates the use of generative AI, oh, did we answer that question? Wait, it just popped away. How long do you think the evaluation will take? Another question is, how long will the whole process take from proposal to implementation?
It really varies quite a lot.
Yeah.
So at Dell, we have implemented company-wide processes to make sure that we are consistent in how we approach generative AI projects across the board. So we have steps like various gates, like your own business unit have to make sure it's a priority. The review from the legal, privacy, security, central AI offices, all IT, all those are done. And then we also want to make sure it is a priority for Dell. So it varies a lot depending on whether it is something that's either highly prioritized or highly communicated. It can affect how long the process takes. If it's a project that nobody has heard of and they have a bunch of follow-up questions, it could take longer.
Great. And I just want to remind the audience again to put your questions in here. We have about 9 more minutes left. So if you have any last minute burning questions, to please add it into the chat. So another question came in, Jennifer, is we have well-known static and dynamic testing tools like Nessus, Burp, Qualys. Do you like to recommend any specific tools for AI LLM applications to identify OWASP top 10 risks?
We don't actually. Part of what we're doing is we're trying to figure out internally what are some of the best ways to manage and implement the mitigation actions I talked about. It's not going to be down to specific tools. A lot of those tools are still coming up with the exact controls. So it's going to be a combination of leveraging those tools and also adding to some of our existing controls to incorporate AI.
Great. And so, can you share some compliance requirements or regulations industry should use for hardening apps or softwares with AI?
Actually, I would say start with what you already have. So making sure that you have the proper logging and monitoring tools, make sure you have the proper endpoint detection and response tools, the right antivirus tools. And then with AI, a lot of it is taking what you have already, even in the absence of AI, and making sure that you incorporate AI threats into it. So for example, do you have a threat library? Does that incorporate the various AI threats? Can you work that into your potential threat management to understand what are some of the different opportunities where a bad actor could take advantage of your environment, and do some exercises to figure out how you would handle that. So it's more about it's really taking advantage of the robust hardening stack that you may already have and making sure that you are able to incorporate the AI threats into them.
Thank you. Another question is, do you allow third-party vendors like GenAI to provide you services?
We do, but it's not a universal yes or no answer. Everything has to go through the AI review board, even if it's a tool that we were already using for a long time. But if they started to introduce a brand new Gen AI capability, we want to make sure that we actually understand how it's going to be used, how it's going to affect our processes before we actually allow that capability to be turned on.
Great. So we're getting a lot of thank yous again, Jennifer, that are coming in through the chat. So thank you for an insightful talk and a Q&A. And I believe a lot of these questions have already been answered. We have some repeat questions coming in, but for the audience members, we really appreciate your time and attention, you sharing your morning, afternoon, or evening with us. Again, this is content that will be available on the WiCyS website, on the WiCyS Bright Talk channel, and then on our YouTube channel as well. You could reach out to WiCyS at info@wicys.org for additional information, or if you have additional questions for Jennifer. But for now, I believe that was just a fantastic webinar. We're so grateful for Dell Technologies for being a strong strategic partner of the WiCyS organization, for supporting our mission, and for bringing folks like Jennifer forward to present this information for all of the WiCyS community. So thank you for sharing part of your day with us. And Jennifer, appreciate you. And I'm sure the audience members know how to reach out to you on LinkedIn. Did you share any additional information about yourself, your contact information or ways to connect with you on LinkedIn. If they have any questions, could they reach out to you specifically?
Sure. Sure.
Wonderful. All right. Well, that's a wrap, my friends. Thank you so much for everything. Appreciate you all and have a lovely rest of your day.
Thank you
Thank
for
you.
having us, Lynn.
Thank you. Bye-bye.